My name is David Derocher. I'm the president of EastCoast CAD/CAM, and I'm joined today by Randy Swaim, my vice president. Today we're going to talk about building information modeling as it relates to a mechanical piping and plumbing contractor. We're going to explore some of the information that we've gathered from our customers and prospects and discuss some of the primary challenges and opportunities that are associated with it. As building information modeling continues to take the main stage, and as it continues to evolve from concept to reality, most notably by showing up in various forms in your bid documents, I wanted to discuss the topic and identify how we may be able to help you meet your requirements. Some people feel that BIM is a software tool and that true BIM means working directly inside a Revit MEP from building conception to fabrication and through to facilities management. I strongly disagree with this. BIM is a process that uses various best-of-breed tools to gain efficiencies, eliminate waste, and provide data exchange that enables collaboration both internally and also with other players on the construction project. As a software vendor, we often find ourselves on the front line answering questions about our BIM integration capabilities. In my experience, most contractors that I speak to are uncertain about what is needed today and what is coming in the future. Many of their comments and questions come from information that they've gathered from or been presented by Autodesk sales and marketing, third-party software vendor sales and marketing like ourselves, industry trade shows and publications, peer groups, and real project bid documents. The information gathered from the first three resources is certainly interesting, it's informative, and should be considered. However, I believe the focus should be on the last two items, peer groups and bid documents. Those are the most useful in looking at the real challenges you and your fellow contractors are facing today. So while BIM may be a modern term, much of what it teaches is not really a new concept for contractors. Many contractors like yourselves have been working in 3D and have established BIM-like workflows to make your shops more efficient. Some of you for over 30 years now. The difference today is that BIM is becoming a standard requirement on projects, and the rest of the construction industry is now coming on board. And this presents both opportunities and challenges for contractors. So with the rest of the industry becoming involved in BIM, more and more contractors are now able to get their hands on real 3D engineered models of the buildings, both prior to bid and when the job is awarded. As these models continually become available, folks using EastCoast design to fabrication tools have a clear advantage. Our software tools can be used to streamline your existing internal BIM workflows, take advantage of new BIM opportunities, and also meet the needs presented by new BIM challenges. With that, I'd like to switch over to Randy so that Randy can demonstrate how contractors can take advantage of the 3D engineering drawings that are becoming available to them.
Well, hello everyone, Randy Swaim here. I wanted to take you through the design to fabrication software here and what we're getting as feedback from some of our clients and our customers. Design to fabrication can take Revit models up to 30 times faster into fabrication than traditional methods. The traditional methods being having to take the model, maybe overlay it over on a PDF, and redraw the piping and the duct onto the model, not utilizing the tremendous amount of hours that was spent by the engineering firms creating this drawing. We have time and time again proven this out by taking the models they send us and converting them into fabrication and then giving them the exact feedback that it's taken us to do these conversions. A lot of times the contractors, after they purchase the software, will exceed the up to 30 times faster is the feedback that we're getting on this. And we believe that makes a good testimony of the software. And you're working in a proven platform, your AutoCAD MEP platform, to establish your workflows. We are not naive enough to think that you can take and just push a button and get the engineer's layout to go straight to fabrication. There is an established workflow and one that needs to be followed to make sure that you correct any of the obvious problems. So I'd like to take you through that workflow today and just show you how we can take the piping and bring it over into AutoCAD MEP, manipulate it, get our reports out of it, and get an estimate out of it. So with doing that, I've simply got a Revit model up on my screen here everyone should be seeing. And I'm going to go over here and I'm going to narrow this down. So I'm going to simply come up here to View, over here to the Visibility Graphics, and I'm going to go to my filters. So in the filters, I've gone through here and I've got some different systems in here. I'm going to tell it that I want to turn off everything except the domestic hot water. So if I go ahead and hit that, now that's left my domestic hot water here. I'm going to go ahead and just go ahead and tab through this to select that system here. So I'm just going to go ahead and tab to select the entire system. Then I just come up to Add-ins and say I want to export this selection. So now I'm going to export this selection, and we're going to call this the domestic hot water. So just go ahead and give it the domestic hot water on the end of the CSA theater. And we're going to go ahead and just say we want to save that into my demo folder on my desktop. Once that's done, I can simply come back over here and tell it to hide the element. Now that piping won't be there when I come back and go to get something else out of the model. But now I'm just going to jump into the AutoCAD MEP platform. And we've loaded up the real manufacturer's catalogs into the runtime catalogs of AutoCAD MEP, utilizing all the tool sets AutoCAD MEP has to offer, but doing it with real manufacturer's content. So what we'll do now is we'll tell it we want to import the domestic hot water system. But before I do that, I want to bring your attention to what we've set up to do this with. If I come over here to my Fabricate and I go to Pipe Fabrication Preferences, I can come over here and I can select from any of my different preferences, and I'm going to bring this in as copper. So when I go through there and I specify that, it knows when it sees a particular valve, it's going to bring in this valve for me. But if I wanted to select other valves, you can see I can make my selection from a very large list. As we move down here for other fittings, caps, couplings, etc., traps, those can be set up because they're not necessarily a routing item that is going to be brought in when we use the routing preference. But I'm just going to go ahead and hit OK. So I just wanted you to see where we're mapping that data. So then by just coming over here and saying I want to insert this Revit model, I'm just going to now go ahead and grab that. And as I bring that in, I can select what preference I want to take this to. And again, I said I wanted to bring that in as my copper solder. So I'm going to go ahead and hit Finish, and I'm going to let this go ahead and run through the process of converting this from generic Revit families into real manufactured content. It makes no difference whatsoever of how that system was drawn in Revit. It could be drawn in plastic, it could be drawn in threaded, and then as I import it, I can change and say, no, I want this to come in as copper, which is I'm doing in this case, and we've got it set up to use NIBCO's copper line to bring this in with. It's looking at the coordinations or the locations of this, the sizes, and all the information necessary to bring this in. The larger the file, the longer it takes to bring it in. If I remember right, I believe this is going to have around 1,500 lineal feet of pipe in this one file. But if you'll notice down here in the lower left-hand corner of my screen, where you'll see a flashing cursor, it's 60% complete of bringing that piping into the AutoCAD MEP at this point. In just a few seconds, we'll see this piping paint up on the screen, and then we'll be able to go through here and see if there was any errors and what we need to do to correct these errors to make this a true fabricatable system. So shouldn't be but just a couple of more seconds here, and we should have that piping appear up on the screen, and there we have it. So now what I'm going to do is I'm going to flip this into an isometric plane, so just gone ahead and taken that into a different view. And now we're going to come in here and we're going to fix whatever problems came in with the system. But before we do that, I wanted to point out just a couple of things here. When we were talking about the valves, you'll notice now as I hover over that valve, that's the valve that I'd specified for this to come into. And so it automatically brought that valve in, and it shows the operator lever in both the open and the closed position in case that causes a coordination issue. So what I'm going to do now is I'm going to come back here, and as we come back up to our Home tab, we come over here to our command. We have here our error log. So this gives me what errors the system caught as it was importing in that system. So the engineer has maybe drawn something that didn't have a real-world fitting to make happen what he was trying to accomplish. But this has jumped me right to the first error here, so I can see as I click onto this right here and I get my grip, I can see that the error is it was a female-to-female joint conflict. So I need an inch to a half-inch transition. So I'm just going to go ahead and I'll just move my error log out of the way, And I'm going to go here and say I want to grab my 1/2 inch now, and as I move over here to my other pipe right here, I'm just going to have it go ahead and hook that up, and now that's fixed my first error. If I jump to the second one, same thing. Again, as I come over here and I click onto this, I can just grab this, say I want to come over here now and I want to change this also down to 1/2 inch. So just by selecting that and then coming back over here to the pipe that I want to connect it to, now I have that error corrected. We'll go ahead and just finish this model out and making these corrections here. And here I've got a 2 inch to 1.5 inches where I want to come over here and I'll grab my 1.5 inches. Just come right back here and say let's go ahead and fix that up here. Accept that. We got 2 more to go. So as I come back here, I'm going to grab this one. I want this one to come down to 3/4 inch. So as we grab 3/4 inch, and then we'll just simply come over here and touch it onto the pipe that we want it to attach to. We've accepted that. And now last but not least, we come back, we'll grab this one, and this one's going to go to another 1/2 inch reduction here. So I've gone through there now, and I've taken this entire model, I've brought this in, and I've corrected the errors that were in the model. But in addition to that, that's brought that in as long lengths of pipe. If I come over here and I click onto this length of pipe right here, the engineer drew that as an 83-foot long piece of pipe. What I'm going to do now is by taking this pipe, I'm going to go ahead and I'm just going to right-click this and go to my pipe lengths and say I want to come over here now and I want to put this into 20-foot lengths, and I want to select my objects to do so. So I'm just going to sweep the model here and tell it to go ahead and apply that. So now that's going to go ahead and it's going to break all my joints down into 20-foot joints and add my couplings where they need to be added. So when I go get a bill of material, I'm going to get true cut links, etc. out of there. So it's where it's added my couplings and broke that pipe down into my 20-foot links. From this point, we may want to come in here and start maybe making a few little spool drawings in here. And I'm just going to do a couple here just to demonstrate some of the power of the fabrication process. So as I come back over here, I'm going to open up our fabrication palette, and I'm going to go ahead and click on the tab Pipe Spool. From that, I'm going to come over here and say I want to create a new folder, and I want to come over here and I want to name that folder that this is going to be my domestic hot water spools. So I can create any kind of folder structure that I choose to. I'm going to say I want to take now and I want to maybe have some spools here. Maybe I want these parts right here to be included in the spool. I'll go on up and just leave that at that point. Now I'll come back here and say I want to define a new spool, and maybe I'm just going to pick these objects right here as the new spool. And we'll go ahead and do one more. So I'll go ahead and I'm going to go back here and say I want to do one more spool here, and we'll grab all of this information here. Maybe I'll even come down here and grab that elbow. I want that in the spool. And so now I've created this, actually only created 2 spools. I've created this as a one large one. But I'll come back over here now and I'm going to click at the top level and just say generate the spool drawings for me. So as I go through there, you'll notice a little flash at the bottom of the screen. So now when I come back, I can say I want to open that spool. And now here's my spool drawing brought in with all of my cut links of all my parts, all of my fittings laid out, and I can even, if it was a welded system, I would count the welds part. But this is the schedules up here for the reports, and they're all customizable. Of course, the title block is customizable. This is a simple viewport. If I wanted to come in here and say, well, I want to change the view of this spool to maybe this view, I want to come back now and reattach all the pipe bubbles. And now I want to come back here and I want to put all the dimensions on that, even the offsetting dimension for that 45 roll there. So just that easy, we can produce our spool drawings right out of the model. When we come back to the model now, I can go in here and I can close this spool out. The system knows that it's been spooled and it knows that it belongs to that. So if I touch onto that piece of pipe and come over and look at my extended data over here, as we move down into this, you're going to notice here that that's part number 5. It knows that that's part number 5 with spool number 1. So all of that information lives with it, and that's the true I in BIM. The information stays with the parts. But if I wanted to come through here and color code that, I could simply just come in here and type spool on my command line and tell it I want to go ahead and lay a legend into the drawing, and I'll just lay that in, let's say over here. And now when I say apply that, it goes ahead and color codes my spools for me here, so I know what has been spooled, where spool 1 stops and 2 starts. So that's the way we can get our fabrication information out here. Also, once we've done that, if I want to go back to my original layers, I can just simply come back over here, click back onto my legend, disable that, now I'm back to my original layers. Let's go ahead and take this back to the top view, and I want to come back in here and I want to look at my layout here. Maybe I want to add some hangers to the model. So I'm going to go ahead and I'm just going to click onto a piece of pipe here, and I want to go over here and I want to add hangers. And so now I'm going to pick a particular hanger preference here, and I'm going to tell it that I want to go over here and I want to add trapeze hangers, and I want to offset to the right an additional 10 inches to pick up that other pipe. And we'll go ahead and we'll just go ahead and say maybe we want at the top of that an adjustable beam clamp. So I'm just going to go ahead and hit OK on that, and that's going to go ahead and calculate my hangers for me down my run. So if I come over here and put this into the object viewer to just take a look at this, we'll just flip this into an isometric plane as well. Now you can see the hangers that I picked up, and I used an adjustable beam clamp, and so I gave myself some space on the top of that to get my wrench, because that can show up as an interference if I don't have enough room to get my wrench onto that clamp. But then we have all kinds of other reports that are available out of the model. I'm going to go over here and say I want to go to attach the data to all my parts. And all this does is attach all the property sets necessary for creating the reports. So when I come back now, I'm just going to go ahead and group this and say now I've got a cut length of every piece of pipe in that model. And it's done it by size. And if I want to come over here and modify that schedule, it's just simply as easy as coming back over here saying I want to come back now and I want to modify the lengths, and I want to add a total for each length. So now when I go back into my model here, here's where I was telling you I had about 1,500 lineal feet of pipe into this model. But that's every piece of pipe, and same thing if I want to come over here and I want to grab all the fitting information. By simply grabbing that, now I've got all my fitting counts, whatever I need to buy out, you can all download to an Excel program so you can get your reports out however you choose. So now from this point, let's say we want to take this and we want to get an estimate on this. So what I'm going to do now is I'm going to switch over here to my Estimate tab, and I'm simply going to come down here and select Attach Estimate Data. So as I go ahead and swipe the model and enter, it gives me my work breakdown structure. So I'm going to come in here and tell it that I want to put this in here as my CSV theater. And now I want to come to, maybe I want to give it a zone. I'm just going to say this is going to be the first, or let's say west. And so now I'm just going to hit OK. So what this is going to do, this is going to create me a tree structure over here that I can now grab that and say I want to export all this data out, and I'm going to do this back to my demo folder on my desktop. So if I just go back to my demo folder, and again we can just call this domestic hot water, and I'll just go ahead and save that. So now I've extracted that out of the model. Now I'm going to come over to Quote Software's piping program, and I'm going to go over here and say we want to set up a job. So I'm going to say I want to set up a new job, and again, we're going to just give this job the name of CSV. And if we want to use a template, we can here, and I'll just say I want to use that heating and cooling template, and OK. So now that we've set the job up, now I want to come over here to my zones, and I want to add a new zone. And again, we can pick a spec name if we want here. We can come back in here and say I want to put this zone is going to be west, and just hit OK for that. Now I'm in the takeoff screen for Quote Software. I'm just going to simply select BIM and say I want to import the EastCoast CAD file. So there's that domestic hot water that we grabbed right there. I'm going to say I want to go ahead and bring that in. So that goes through there and looks at that file, and it comes up here and it tells me that it's going to import this. But it's going to ask me now, import items by spec and supplier code. Do I want to edit the mapping? I am going to edit the mapping just to show you where this comes from. So when we look over here, there's a legend that shows me that spec items are blue, database items are purple. Red means these items need to be mapped. So if I look through my list over here and see if I have any red items in here and can see that I don't, I'm ready to go ahead and import this. This thing has a intelligent mapping, so once you map it once, it remembers it from then on. So if you map one 2-inch elbow to a 2-inch NIBCO elbow, it'll remember that from then on. So I'm just going to go ahead and save this mapping and say now go ahead and import the file. So now just that quick, it's imported all of those items, 382 line items of pipe. So now if I come back over here, I'm just going to say let's go ahead and save that takeoff. And then we're just going to close out of this. And we're going to go back over here to our calculations. And I'm going to tell it go ahead and calculate the job for me. So now it's showing me a material cost here of $13,300 roughly, and labor hours here of 171 hours to install that piping. So what I'm going to do now is I'm going to come right back into the zone information, and I'm going to go ahead and open this zone. So I'm just going to come back in here and double click on this to open it. Come right back to BIM, and now I'm going to say I want to export this, and I want to export this right back to that same file. what this is doing is captured all the labor and material and brought it back into that file, so that when I come back into AutoCAD MEP and I go ahead and say, now I want to bring this file back in, by just simply selecting that and selecting that domestic hot water file, that's bringing all that material and labor data right back into the model. So if I come in here to look on one particular item, maybe if I come over here and I touch this elbow now you can see here's the material and the labor to install that elbow, giving me complete control over pricing of the model and manpowering of my job. So if I know that I'm going to come in and I'm going to be installing, let's say, this portion of it this week, I can simply come over here and say, I want to come over here and I want to get an estimate schedule, and I'm just going to be installing this part right here. Now it's giving me a schedule that's going to give me my total material and my total hours to make that installation. So we can break that job down and manage it to a much higher level by having all the labor right in the model. Now when I want to send this model out to someone, I have the ability to come in here and strip that estimate data out of the model. So none of your vendors or GCs see your labor units. Only this is for your internal use. And with that being said, that's taken us from design in Revit all the way into AutoCAD MEP, creating our spool drawings, getting an estimate, and having all our reports available. And that'll conclude my portion. I'm going to turn this back over to David. Thank you.
Thank you, Randy. So at the beginning of the presentation, we talked about BIM bringing both opportunities and challenges to contractors. We discussed some of the lucrative opportunities associated with BIM, but I also wanted to explore some of the challenges. Project deliverables for communicating with the other stakeholders on the project are changing. They can vary widely from project to project. They're not always well understood, even by the folks making the requirements, and as such, they are not always clearly defined. Some of the more common deliverables that we've seen or heard about are DWG, DWF, and PDF for approvals. Navisworks, pretty much in large part for coordination. DWG, ACES solids with annotations. RVT and IFC for as-built drawings. And then IFC and COBE for facilities management. ECCAD for AutoCAD MEP provides lots of functionality to share model data in various formats and currently supports DWG, DWF, PDF, Navis, ACES solids with annotations, IFC, COBE, and many more. Just as a note, EastCoast participated in and we won the 2013 COBE Challenge for our focus group, which was the mechanical duct, pipe, and plumbing contractor. For those of you that are not familiar with COBE, COBE promises to digitize the documentation handover required to operate and maintain the building for the life of the building. But more recently, we've been hearing from prospects and customers that native Revit MEP deliverables are showing up on project bid documents. To respond to that, and for that reason, we're currently developing the capability to export your AutoCAD MEP construction models back to Revit MEP as native Revit MEP objects. That will extend Randy's presentation to not only show taking a Revit MEP or an AutoCAD MEP model, I guess in this case Revit MEP, but bringing that into the AutoCAD MEP platform for all your construction documentation, but then also being able to send it back natively to Revit MEP as native Revit MEP objects for coordination and for your as-built drawings, and so that you can meet the requirements of any project that comes across your way. So in conclusion, EastCoast design to fabrication software tools support your current workflows. They work well for today's requirements. They're adaptable to meet future BIM requirements, and they should help you make the most of new opportunities. Thank you very much for taking time out of your day to listen to our presentation. We really very much appreciate it. And if you have any direct questions for either one of us, really, then feel free to contact us at the information provided here on the screen.